Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Logarithmic Function Basics. Concept number 3, the common logarithm. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. You have lots of friends, peers, classmates, and or colleagues who are taking Algebra 2 with you, and they could use a boost as well. So tell them, as well as yourself, to inbox me at memedicine@gmail.com to order and purchase the complete cram session. And you'll be glad you spread the word, because everyone taking this course with you, they'll make great study buddies, okay? All right, so let's delve into the concept. Logarithmic function. What is the notation for a logarithmic function when the base is 10? I'll give you a moment to think while I practice pronouncing this word. Logarithmic. Okay, yeah, I think that's correct. All right, so hopefully by now you are able to press pause and come up with an answer. And if not, that's totally fine. But before mentioning the notation for a logarithmic function when the base is 10, we first need to understand the general format for an exponential function, which is the basis for the logarithmic function, okay? The general format for the exponential, or for an exponential function rather, is y is equivalent to base b raised to the x, where b is going to be positive, that means it's never going to be negative, and it's not going to be equal to 1, okay? So when you have this format, what you have is an exponential function. All right? And don't get this format confused with a polynomial function. In a polynomial function, the format is kind of in reverse, where the base is going to be your independent variable x, and the exponent will be a constant such as 2, 3, 4, etc. Okay, but here for the exponential function format, we have our base, which is a constant number, our exponent, and the answer or result, which is called a power. Sometimes these two names are exchanged, but that's actually a misnomer, because the power is the result of an exponential function. So let me give you an example. Let's say you had a base raised to an exponent of 2. This means that the result would be called the second power, okay? If it was, the exponent was 3, the result would be called the third power of b, the base b, okay? All right, so now that we sorted that out, let's talk about the logarithmic function. A logarithmic function is the inverse of the corresponding exponential function with the same base, okay? So this means basically that y is equivalent to the log base b of x. So if these two statements are inverses of each other, an equivalent expression for this statement is going to be x equals b raised to the y power. Okay? Remember that algebraically, in order to yield the inverse function of your starting function, all you have to do is switch the independent with the dependent variables, okay? Or simply put, you just switch the x and y values. So for this or any inverse function, constants are always going to be in the same position or remain the same. That's why they're called constants. But now we see that x is the power or result and y is the exponent, okay? So we had some shifts to yield our inverse functions. And on a coordinate plane, the graph of the logarithmic function is going to be the graph of the corresponding exponential function that we have here, reflected over the line y equals x. Okay, so here goes our logarithmic function graph. And now let's get to this bad boy, base 10. Whenever your base is 10, this is going to be called the common logarithm. And the common logarithm is going to emanate from the exponential function y equals base 10 raised to whatever x power, okay? And the logarithmic inverse of this is going to be y equals the log base 10 of x. So this is basically saying that an exponent y is the exponent needed to raise the base 10 to yield the power of x, okay? So this whole thing is kind of confusing to express. I'm not even sure if I'm expressing it right, but this would be your exponent. This just denotes the base that's being acted upon by this exponent, and the numeral written on the left-hand side is going to be the power or the result. So things are kind of in reverse, okay? All right, so, or simply put, well, let's get an equivalent expression for this. X equals 10 to the y power. These are two equivalent expressions, okay? Or you could say that y equals log of x, and this is referred to as the common logarithm. Whenever you have this statement here written without a base, the automatic assumption is going to be that 10 is the base. So this is the notation for the logarithmic function when our base is 10, okay? Also noted here on our coordinate plane. Writing out the numeral 10 would be redundant in the world of algebra, so you don't need to do that. And log is shorthand for logarithm, just in case you're wondering. Okay. Let's just highlight our answer really quickly. So this is the answer. This is the notation. Once more. And overall, intellectual comprehension of this material was not difficult. And after the short amount of time it takes to complete the entire Cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept, okay? So inbox me at memedicine@gmail.com to purchase and order the complete Cram session. Thanks for tuning in and good luck studying.